Now we look at a lesson on sampling techniques. Some definitions. A census is the most accurate way of collecting information as everyone in the population is surveyed. However, this is both time-consuming and expensive. So therefore a sample of the population is generally surveyed instead. Now, if the sample is to contain reliable information, it should be unbiased and be of a reasonable size. Now let's have a look at some sample types. A random sample. This is based on choosing members of the population by chance. A stratified sample involves selection of people in various categories in the same proportion as they occur over the whole population. A systematic sample, the people are chosen in an organised manner. Right, let's consider this scenario. Surveying every student in Year 8 at Redfield College to compile a list titled Favourite Sports of Redfield's Year 8 Students. Well, given that the list is the favourite sports of Redfield's Year 8 students, we're surveying every one of them. This would be known as a census. What about this scenario? Surveying every student in Year 8 at Redfield College to compile a list titled Favourite Sports of the UK's Year 8 Students. Well, given that the list is the favourite sports of the UK's Year 8 students, and we're only surveying people from Redfield College, then this would be a sample. And it would also be biased because we haven't really surveyed anyone outside only a small specific area. Alright, so for a good sample we need to survey a variety of people, different ages, etc. What about surveying every 100th customer? Well, this would be a sample certainly, and it would be systematic. Alright, systematic and organised way. Surveying people whose names are picked from a hat. Alright, this is again as a sample, a random sample. People are chosen purely by chance. Now let's create a random list. Okay, there are ways of doing that. The calculator. The calculator can generate random decimal numbers such as 0.329, 0.485, 0.811, 0.932. Now if we wanted to choose 4 students at random from a class of 35, we could assign students a number from 1 to 35 inclusive. We could then generate 4 random numbers on the calculator, okay, similar to the ones we got above. Now let's say the numbers generated were, in this case, 0.842, 0.317, 0.748, and 0.219. Then on the calculations to work out which students. Okay, 0.842 we multiply by the 35 students. We come up with 29.47. The 0.317, again multiplying with 35, comes up with 11.095. Our third random number was 0.748. Let's multiply by 35 and we get 26.18. Our fourth random number, multiplying by the 35 there, gives an answer of 7.665. So, the 4 students chosen would be those with the following numbers. Alright, the 29.47, we choose student 29. 11.095, we choose student 11. 26.18, we choose student 26. And 7.665, this time we'd round up, wouldn't we? We'd choose student 8. So that's one way of creating a random list. Let's look at another example. The age and gender of all people attending a school concert were recorded as shown in the table. Now if 30 people are chosen to participate in a stratified survey, we need to find how many males in the 10 to 14 age group should be selected. So let's have a look at all the males there, count them up, come up with 80 males. Alright, now before we go any further we better fill out the whole table. Let's count up how many females. There was 100. So altogether there was 180 in total. That's an important figure. Now, how many males in the 10 to 14 age group? Well, from our table, we can see that there are actually 12 males, okay, in the 10 to 14 age group who attended the concert. Now that 12 is out of the 180 in total. So we write the 12 on 180, then we multiply by the 30 people that we're going to choose. So let's multiply by 30 and we come up with 2. So 2 students out of that 30 would be a good representation in this stratified survey. How many females should be selected? Well, let's look at the females there. There was 100 in total. So as a fraction, they made up 100 of 180. So we use that fraction, multiply by the 30 people for this survey, and when we calculate that, it works out to be 17. Okay, we've rounded that off to the nearest whole number. Excellent. Well, that concludes our lesson. Good luck with your questions.